The correct answer is B, 3 volts. To find the total current in the circuit, first determine the equivalent resistance by adding the 3 resistance values. For these 3 resistors in series, the equivalent resistance is 60 ohms. You can redraw the circuit showing one resistor with a resistance of 60 ohms, the equivalent resistance. The voltage drop across this equivalent resistor is 9 volts. Use these values to determine the current in the circuit. The voltage across the resistor is 9 volts and the resistance is 60 ohms, which gives a current of 0.15 amps. This 0.15 amps flows through each resistor since they're in series, so the voltage across the 10 ohm resistor is 0.15 amps times 10 ohms, which is 1.5 volts. Similarly, the voltage across the 20 ohm resistor is 3 volts and 4.5 volts across the 30 ohm resistor. Add these voltages together and you get 9 volts, which is the voltage of the battery. Now take those 3 resistors and connect them to the battery so that each resistor has one end connected to the positive terminal of the battery and the other end connected to the negative terminal. When wired this way, the voltage drop across each resistor is equal to the voltage of the battery. The voltage across each resistor is the same as the battery voltage because each resistor is wired in parallel with the battery and therefore also with each other. The total current flowing in this circuit again depends on the battery voltage and the equivalent resistance, but since the voltage drops across the different resistors are all equal, there will be different amounts of current flowing through each of the different resistors. These 3 currents will recombine and result in the total current I after passing through the resistors. To determine this total current, first find the equivalent resistance for these 3 resistors in parallel.